Now that we talked about doing reinforcement learning in a POMDP setting, we're actually now going to talk about a much weirder combination. We're going to talk about how we can think of reinforcement learning as actually being itself a POMDP.
Okay.
This is an area that is often referred to as Bayesian reinforcement learning. The idea is that we're going to keep a Bayesian posterior over possible MDPs that we're in, and we're going to use that to actually optimally balance exploration and exploitation. So we're actually going to behave optimally, and reinforcement learning becomes planning.
Okay, so does it mean we're going to use Bayes' rule?
Well, I guess technically, in that whenever you compute a posterior, you're actually doing something like Bayes' rule. Yeah. So, but maybe this is not so clear. Let me try to draw a picture. So I'm hoping this example might make things a little bit clearer. So let's consider a really simple reinforcement learning problem. We've got two states, state 1 and state 2. Two actions, a black one and a, purplish kind of one. And so if we were doing reinforcement learning in this environment, and you were, say, the reinforcement learner, what would you do? Let's say we're in state 1. What would you do? Would it be better to do purple or black?
I don't know.
Okay, so then what would you do?
I'd pick one of them.
All right, so let's say you pick black.
Okay.
And then we observe a transition, and ultimately we can sort of build out a model or use Q-learning or something like that to work out the values. So what I'd like to do is actually try to have you think about this like a POMDP. And I think a simpler way to show you that would be, instead of imagining all possible MDPs that this could be, let's just pretend it comes from a small finite set.
Okay. Are there any small sets that aren't finite?
No.
Good. Then I think we're on the same page.
All right. Then I agree with you. So here's the set that I had in mind. We've got 3 possible worlds that we're in, A, B, and C. So these are 3 possible MDPs, right?
Okay. And they all look exactly the same to me except where you get reward.
Yeah. So it just so happens that the actions all do the same thing in all 3 of these. And we know that. We just don't know where the reward is. Is the reward something you get for purple when you go from state 2? Is it something that you get for purple from state 1? Or is it something that you get from taking the black action from state 1? And we don't know. Now, if you had to solve this reinforcement learning problem, it's kind of a reinforcement learning problem, right? You're in some state. You get to see which state you're in, 1 or 2. You can try actions black or purple. And what you're trying to do is actually figure out how to maximize reward. But now that it's just a finite set of possibilities, we can think about this like a POMDP.
Sure. And in fact, I think this one's pretty straightforward. If I'm in state 2, I know what I should do.
And what is that?
I should take the purple action.
And why is that? Explain.
Because I either immediately get reward for it, or I know that I get reward for being in state 1. And then when I'm in state 1, well, actually, it's not clear which one I should do.
All right. So let's do 2 things. Let's start off by just tracking belief states in this, because I think that's already kind of an interesting problem in and of itself. What we're thinking about here is that we're in a POMDP with 6 states. If in state 1, but we don't know which MDP we're in, then the belief state's going to look something like this. Agreed?
Agreed. If this is where we're starting and we know nothing else and we haven't done anything yet, then we can be in any of those states, presumably with equal probability.
Good. All right. So now the question is, if you were to do the purple action from here, what would your expected reward be?
My expected reward would be 1/3.
Right. So if we happen to have been in MDPB, which we don't know if we are, and we took the action purple, we'd get a 1. If not, then we'd get 0. But what also would happen if we get the 1? What's our new belief state?
If we get the 1?
Yeah.
Well, then we know that we are in B1.
Good. B1. Right. So we're in this state. So the belief state becomes basically fully observable at this point. We know which MDP we're in, and we know what state of that MDP we're in, and we can just execute the optimal policy for that MDP, which in this case, as you might guess, is just purple all the time.
Purple all the time, purple all the time. Yeah, I agree.
Excellent. So let's make sure you get this. We'll do a little quizzy kind of thing.
Okay.